morning children, welcome back. In our previous video we have seen about the motion, the types of motion, what is speed, how to calculate the speed. Okay, I hope you have learned the formula, that is speed is equal to distance upon time, correct? And now we will see that how this distance and time graph is plotted. Okay, you can see the picture over there of a graph. The distance traveled by a car and time taken is shown in the table below. Okay, see the table. There's a little printing, the typing mistake over there. Just after 1 minute there is 2 minutes, then 3 minutes, then 4 minutes and 5 minutes. Okay, just keep in mind, there's a typing mistake. So first 0, that is the car is in rest. Okay, then after 1 minute they have started. So at 1 minute it has covered 1 kilometer. After 2 minutes it has covered 2 kilometers. After 3 minutes it has covered 3 kilometers. After 4 minutes it has covered 4 kilometers. After 5 minutes it has covered 5 kilometers. Okay, now start plotting the, take these measurements and start plotting the graph. So how to plot the graph? Firstly you have to take the graph paper, then on the vertical line is known as vertical, what we have to plot, the distance in kilometer is the y-axis, and the time in minutes is known as the x-axis. So on x-axis you can take as 0, 1, 2, 3, 4, 5, 6 the time in minutes, and the distance in kilometers as 0, 1, 2, 3, 4, 5, 6 in kilometers. Next, take the first 0, okay, the time 0, distance 0, so no need to plot. Then is the 1 minute. At 1 minute how much distance it has covered? 1 kilometer. So keep a point of the both the take the middle of both the axes, you can get the 1 minute. Okay, then 2 minutes, then 3 minutes, 4 minutes, 5 minutes and 6 minutes, and then join all the dots you have taken over there. Okay, so that is we get the straight line. So if the distance time graph is a straight line, then the object is moving with a constant speed. If the speed keeps changing, what will happen? The time is 1, 2, 3, 4, 5, 6. Okay, but if the distance changes, that is if the speed changes, what will happen? The graph will move, correct? The points will move up and down. So the graph can be of any shape. Okay, a distance time graph shows how far an object has traveled in a given time. It is a simple line graph that denotes distance versus time findings on the graph. So why to plot this graph? You have calculated the speed, then why to plot this graph? When there are many examples or many things to calculate the speed, you have to just think of that, you can't go on that place and see that how much they have traveled, how much was the speed. Each time you cannot just calculate and see what is the your speed uniform or not. Okay, you can't go through every typical speed. Okay, so in that case what they do, they just plot a graph so that they can, after seeing the graph, they can see how the movement of the speed, how the movement of the car or how the movement of the object is going on. Is it in the uniform motion or is it in the non-uniform motion, or the object is at rest? Okay, so that's why the distance time graph is plotted, so that they can know that how the process of speed or how the process of motion is going on. In this, most important part you have to remember is always the time is plotted on the x-axis and the distance is plotted on the y-axis. Okay, so the curved lines on the distance time graph indicates the speed is changing. Okay, from the graph we can find the speed of the bus at any instant of time. The initial and the final position of the car can be found as following, that is speed is equal to final position minus initial position upon time. So if the graph is given to you, from the graph also you can find out the speed. So for that the formula is final position minus initial position upon time, that is the speed. Okay, from the graph you can calculate. So the conclusion of this distance time graph is, if you have a straight line graph, then it is known as uniform motion. Okay, there is no change in the speed. The speed is constant, that is uniform motion. If you get a curved line, now you can see a bended curve. Okay, you can also see a mountain curve also. So that also is a non-uniform speed. Any curved line, whichever direction the curved line is, the speed will be non-uniform speed. And if there is a straight line that is parallel to x-axis, okay, you have to remember, if a straight line is parallel to x-axis, then the object is stationary. Stationary means what? They do not move from their place. Okay, the motion is not there in the object. Okay, so in the conclusion you have to remember of distance time graph, that is uniform motion straight line, non-uniform motion curved line, and stationary, that is straight line parallel to x-axis. Okay children, so in this lesson we have learned about motion, various types of motion. Then there is a uniform motion, non-uniform motion. The types of motion we have seen of periodic motion, circular motion, rectilinear motion, correct? And then we have seen the distance, how to measure the distance, then the speed, how to calculate the speed. If you know the distance and time, the formula will be speed is equal to distance upon time. If you know the speed and time, then the formula will be speed into time is equal to distance. Okay, when you have to find the distance, then if you have to find out the time, then the formula will be time is equal to distance upon speed. Okay, next we have seen about the clocks, various types of clocks. They all the clocks have the periodic motion, correct? Then we have seen how to calculate the speed and how to plot it on the graph. Okay, thank you children.